Lesson 17 is called Graphs of Cosine Functions, and it's going to be really similar to Lesson 16, which was Graphs of Sine Functions. We're just going to have a different parent function since we're basing our graph off cosine rather than sine. So 17.1 is the midline and amplitude of a cosine function, and we're going to start by graphing the parent function from the unit circle. So for cosine, the parent function is f of theta equals cosine of theta, and we're going to make a table for it. Before we can fill in our table, we have to remember that from the unit circle, cosine is the x-coordinate from each point. And that was because cosine is usually adjacent over hypotenuse, but on the unit circle that translated to the x-coordinate over the radius, but the radius is just 1. So it ended up just being the x-coordinate. That was from our previous lesson. So on the unit circle, cosine is equal to x, and that means that it's going to be the x-coordinate of whatever point is kind of situated near the angle. So for our first input value, it's 0. So if I go to the angle 0 right here, and they're all of our input values are going to be in radians, I find that angle, and then I look at the point that's at that angle, which is 1, 0, and in this case, I'm looking for the x-coordinate since it's cosine. So the x-coordinate of that point is 1, so f of theta is going to be 1, because cosine of, in that case, 0 for that input value, cosine of 0 is 1, since the x-coordinate is 1. And then our next input is pi over 2, so that's up here. And then we're looking at the x-coordinate from that point, which is 0, so our output there is going to be 0. Our next input is pi, which that angle is right here. And then we're looking at the x-coordinate from that point, which is -1. So we'll put a -1 right here for the output. And then our next input is 3 pi over 2, which is down here. And then we're looking for the x-coordinate at that point, which is 0. So we'll put a 0 right there for the next output. And then our last input is 2 pi, which is back here at the beginning. It doesn't say it on this graph, but 2 pi would be 1 full rotation around the unit circle. So it's at the same spot as 0 was. So we're looking at the same x-coordinate, which is 1. So 1 would be our output there. And then we'll set up our graph. We're going to set it up pretty much the same way as we did when we were doing the parent function for sine. So we have kind of like the vertical axis is going to be more kind of shoved towards the left. And then when we scale our horizontal axis, it's usually like x. In this case, our input is theta. So I'm just going to put a little theta there. And then we only need to go as far as our table goes. So for theta, we're going from 0 to 2 pi. So 0 is going to be at the origin, and then I'll need like 4 marks after that. So I'll cut my horizontal axis into fourths, and I'll label each of those. So 0 will be at the origin, and then this will be pi over 2. The second one will just be 1 pi. The third will be 3 pi over 2, that's like 1.5 pi, and then the fourth tick mark will be 2 pi. And we talked about it before, but all these like input values, pi over 2, pi, 3 pi over 2, and 2 pi are all the same distance from each other, or they're all half a pi apart from each other, or like 1/4 of the way around the circle. And then for our like vertical axis, we just need to look at like what are our output values scaling between. So like our highest output value is right here, it's 1, and then our lowest one is -1. So we just need to go up to +1 and then down to -1 on our vertical axis, just like we did with sine. Okay, so now we're ready to go ahead and graph our points. So the first one is 0, 1, so that means I would not go left or right at all. I would just go up 1. That would be the starting point of my graph. And when I say starting point, it's just kind of like the first one we like plot. It's the y-intercept, but the graph will continue in like left and right forever. And then the second point, pi over 2 and 0. So I'm going to go over to pi over 2, and then I won't go up or down at all since the output is 0. The third point is pi and then -1. So I would go over to pi and go down 1. Fourth point, 3 pi over 2, 0. So I would go over to 3 pi over 2, and then I would not go up or down at all. And then the last point is 2 pi 1. So I would go over to 2 pi and then I would go up to 1 right there. And then sine and cosine graphs are really just like a wave shape because they're found by like rotating around the circle, and when that's applied to a graph, it ends up looking like kind of like just a smooth wave. So I included down here, this graph is the parent function for cosine. It just has kind of some more points filled in so that we can see the shape of the graph. But it kind of looks like, I don't know, when we draw it up here, like it could very easily kind of look like a V, but it's important to know that it's like a smooth wave. So when you go to connect your points, try to draw it as if it's like kind of curving. I don't know, I know I keep saying the word smooth, but as smooth as possible. And then this graph will continue to like the right forever. It'll just oscillate in the same pattern. And then the same thing with the left. It'll kind of oscillate to the left as well. Okay, so there's a few key points I want to point out on this graph. So we talked about on sine. Sine started at the midline, which we don't have the midline drawn on here yet, but we can go ahead and put it in. It's the same thing as it was for sine. For the parent function, this midline is right here, which is at y equals 0. It can vary depending on like what the graph is, but our midline would be right there at y equals 0. And then for cosine, like this is a cosine graph, cosine starts at a maximum. So like all the way up here at 0, 1, that's a maximum, and that's where cosine starts. So sine started at the midline itself, and then it went upward. Cosine starts exactly at its maximum, and then it goes down from there. And then halfway through the like cycle, cosine is going to hit a minimum down here. And then at the end of the cycle / like at the beginning of the new cycle, it's going to hit a maximum again. Okay, so whenever we graph these like sine and cosine, you need to have like 5 points on your graph. These are going to be the 5 points that you'll have on a cosine graph. So there will be the start and the end at a maximum. In the middle, there will be a minimum. And then at the kind of like 1/4 of the way mark, it'll be at the midline. And then at the 3/4 of the way mark, it'll be at the midline as well. So when I graph these, I like to put them like my points in this order. I do the first maximum, the like ending maximum, the minimum in the middle, and then I put those last 2 midline points last. So I would do like this one 4th and then this one 5th before connecting all my points. Okay, so moving down, we've already talked about these formulas with amplitude and midline when we talked about sine. It's the same as with sine. So to find the amplitude, you can take the highest y value and the lowest y value, subtract them and divide by 2. And then to find the midline, you can take either the lowest y value and add the amplitude, or the highest y value and subtract the amplitude. However, these formulas are just really here to fall back on if necessary. Most of the time, you can see the amplitude and the midline from the graph itself, and that's the way I'm going to go through it in these notes. But just know these are the same formulas as the previous lesson, and you can always fall back on them if you need them. Just a quick little review. The midline is a horizontal line that cuts the graph in half. So that pink line, that's y equals 0. That would be the midline. All parent functions for sine, cosine have the midline at y equals 0, but it can move up or down depending on what actual function you're given. And then the amplitude is the distance that the highest or the lowest point is away from the midline. So like our max is right here. This distance is 1, so that would be the amplitude. Or you could go from the midline down to the lowest point. That would be the amplitude as well. Okay, example 1, find the amplitude in the midline of the cosine function. I'm going to use it without the formula, so I'm going to find the midline first, actually. Midline is just going to be something that cuts the graph horizontally, or like it's a horizontal line that cuts the graph in half. So to find the midline, I need to look at what is the highest point and what is the lowest point. So the highest point on my graph is right here at 5, and then the lowest point is right here at -1. So if I want to find the distance between them, there's a few different ways that you can do it. You can find like the average of the two numbers where you add them together and divide by 2, or you can like just count how many units are between them. So like to go from 5 down to -1, it's going down 1, 2, 3, 4, 5, 6 units. So halfway would be 3 units down. And so that gives us a visual of where we could draw the midline. It would be right here at y = 2. So our midline is y = 2. And then what I was saying about like finding the average of the two numbers, think about like finding the mean, where you have to add the two numbers 5 plus -1 and then divide by 2. 5 plus -1 is 4, and then divide it by 2 to get 2. So you end up with the same answer, y = 2. You're just basically finding the middle value between the maximum and the minimum. And then once you have your midline in there, then it's easier to see what the amplitude is. That's why I did the midline first, because the amplitude is the distance from the midline to the highest point or to the lowest point. So either that distance right there, which is 3, or it's the same distance as right here, which is 3. And that's honestly a good place to kind of like check your work. Like if you feel like you're getting a different amplitude, if you're looking at different parts of the graph, then you didn't choose the correct midline, because the midline should be perfectly in the middle of the like max and min. So our amplitude in this case is going to be 3. And the amplitude will always be a positive value because it's just a distance. So amplitude is 3, midline is y = 2. And if you wanted to use the formulas, you would just do for amplitude, then kind of just write it off to the side here. It'll be the highest y value, which was 5, and then minus the lowest y value, which is -1, so 5 minus -1, divided by 2. 5 minus -1 is like 5 plus 2, so that's, 5 minus -1 is like 5 plus 1, so that's 6. And then 6 divided by 2 is 3, and it ended up being the same answer that we got just finding it without the formula. And then for the midline, it was supposed to be taking the lowest y value and adding the amplitude, or taking the highest y value, which is 5, and subtracting the amplitude, which is 3. So it ends up being 5 minus 3, which is y = 2. So you get the same answer. Just kind of like to steer away from the formulas a bit. That way we understand it more on like a conceptual level. 17.2 is the period and frequency of a cosine function, and we talked about period and frequency in the sine lesson, but I'm just going to review those words here. So up at the top, period is the horizontal length of one cycle of the wave. The picture on the right shows one cycle of a cosine wave, meaning this is like one period before it starts to repeat itself, because cosine starts at a high point, goes down to the low point, comes back up to a high point. And then after that, it's just going to be a repeat of the same exact pattern. So the period is that length, and this one goes from 0 to 2 pi. It's how long it takes before it starts to repeat itself. So in the parent function, the period of one cycle is 2 pi, and that's because the parent function comes from just like one rotation around the unit circle. Frequency is the number of cycles that occur within a distance of 2 pi. So you can see like on our graph, we just looked at from 0 to 2 pi and just one cycle happened. So in the parent function for sine and cosine, the frequency is just 1, because only one cycle occurs between 0 and 2 pi, but that can vary depending on the function. So example 1, find the frequency and the period of the cosine function. We're going to just find it without a formula, and then we'll kind of go through the formula after. Same thing as like what we did with sine. So the frequency is the number of cycles that occur within a distance of 2 pi. So if we're starting here at 0, and then we're going to 2 pi, we need to count how many times the wave repeats itself. So it starts at the top, goes down, and then comes back up. That's one cycle, goes down and then comes back up. That's a second cycle, goes down, comes back up a third cycle, goes down, comes back up a fourth cycle, and then goes down and comes back up a fifth cycle. So there's 1, 2, 3, 4, 5 of the same like wave parts repeating itself. So that would mean that the frequency is 5. Because like we said, frequency is the number of cycles that occur within a distance of 2 pi. And from 0 to 2 pi, there was 5 of the same waves cycles, or sorry, like 5 of the same portions repeating itself over and over again. So the frequency is 5. And then, like I said, this is just like, if we're starting here, we're going down and then coming back up. And then I can just literally like drag this over and it's gonna like continue to copy over and over again. So that's just the one like kind of black drawn in line. That's one cycle. Frequency is how many of those do I have between 0 and 2 pi. And then for the period is the horizontal length of one wave on the cycle. So now I like want to find, okay, what is the length of this wave right here? And you can't really tell because it's like there's no tick mark right there showing exactly what that is. But we do know that that one wave, there's 5 of those same like lengths in the span of 0 to 2 pi. So this is really like 1/5 of 0 to 2 pi. So if we want to find that distance, we would do 1/5 times 2 pi. And then you can cross cancel if you want. This one we can't in this problem, but in the future you could if you had the opportunity. So here we'll just multiply straight across. 1 times 2 pi is 2 pi. And then over just a 5 in the denominator. So we have 2 pi over 5 is the period. And that's the like length or how long it takes before it starts to repeat itself after that first time. And then here's the formula for finding the period. It's the same as when we like found it with sine. You take 1 over the frequency, which is what we did here, 1 over 5, the frequency, and you multiply it by 2 pi. Okay, 17.3 is how to graph a cosine function. So, sorry, this is a typo. General form of a cosine function, it looks exactly the same as general form of a sine function, but instead of having sine, it has cosine. So it's y equals a times cosine b of x minus h plus k. All those letters have the same exact meaning. It's just instead of having sine here, we have cosine. So a is the amplitude, b is going to be the frequency, k is going to be the midline, and then h is going to be a horizontal shift. Same thing as when we did the sine lesson. We're not going to do any horizontal shifts in this section, so we won't really be dealing with anything that has an h in there. Example 1 says graph y equals 3 cosine of x minus 2. We're just going to go through and find each letter. So a, that was supposed to be, or that represents the amplitude, and that was the number that's out in front of the function. So in this case, the amplitude is going to be 3 because we have a 3 out in front. Frequency is b. And if you look in the kind of general form, b is this number right here that's in between cosine and x. And so if you don't see a number between cosine and x, then b would be 1. So that would mean that the frequency is 1. And that means that there's one cycle occurring between 0 and 2 pi. So that means it has pretty much the same kind of like structure as the parent function. And then the midline is the number that's added to the end. That's k. And it's going to be a horizontal line. So it'll be y equals. And in this case, k is -2. It's this number right here. So it'd be y equals -2. And then for the period, we're going to use, so you can't actually see the period from the function itself. You have to find the frequency from the function and then take the frequency and put it into the formula for period. So the formula itself is 1 over the frequency times 2 pi. So that means that we need to take the frequency, which we just found was 1 right here. and then we can put it in here. So it'd become 1 over 1. 1 over 1 is just 1, so 1 times 2 pi, it just stays the same. So what that means is that the horizontal axis is going to be scaled the same exact way as the parent function. Okay, so when we go to set up our graph, sometimes it's helpful to think about amplitude and midline before you actually draw your graph. So if you think about midline, that's going to be the middle of the graph. Amplitude is going to be how far you kind of stray from the midline. So since our midline's down at -2 and we're going to have to go like below that, I'm going to kind of draw my graph so that there's a little bit more room on the bottom half of my graph since my midline is negative, and I'm going to go down from there with the amplitude. Okay, and then when we scale the graph, the x-axis or the horizontal axis, it's going to be based off whatever our period is. And then we're going to have to break that down into fourths. So I'm going to treat this as if it's not the same as the parent function and just start it from scratch. Because it's easy to say, oh, just do it the same, but we want to know like how to do it if it's not the same. So our period is 2 pi. So that means that that's going to be the furthest mark on our horizontal axis is 2 pi. Because that's like the length of one cycle, and we just need to draw one cycle. So that's going to be our furthest point. And then we're going to have 5 points on our graph, which means we have to break down 0 to 2 pi into fourths. So to break it down into fourths, I'll do a halfway point, which is just pi, because it's like halfway between 0 and 2 pi. And then halfway between 0 and 1 pi would be like half pi, which is pi over 2. And then halfway between 1 pi and 2 pi would be like 1.5 pi, which is 3 pi over 2. And then now for our vertical axis, our midline's at -2. So we're definitely going to go down to -2. And then we need to think about what our amplitude is, because our amplitude is going to be the distance that we're going to stray from our midline. So our midline's at -2, our amplitude is 3. So our midline will be right here. Our amplitude is we're going to go 3, it's 3 below the midline and 3 above the midline. So I guess I could have even favored the graph even more in the negative range, but it's okay. We have enough space. So, okay, so we have everything set up, everything scaled. This will be 1, -1 right there. And then the first thing I'm going to draw is the midline. So it's at y equals -2. Which is a horizontal line that crosses through -2 on the y-axis. So that'll be right here. And then next we need to know the shape of the cosine graph and like kind of where it starts and where our key points are. So cosine starts at its maximum, which is going to be the amplitude above the midline. So the amplitude is 3, so we're going to go 1, 2, 3 units above the midline, and that's going to be our maximum up here. So this point, that's our max, that's our starting point for cosine. And then we also talked about that's going to be like our ending point. It's going to end at a max as well. So at the end of the cycle at 2 pi, I'm going to put a point at the same height over there. So that's going to be a max also. And again, that's 3 units above the midline because the amplitude is 3. And then the halfway point for cosine is going to be at the minimum, which is going to be 3 units below the midline now because the amplitude is 3. So go 3 below, it'll be right here at pi, and then it's at -5. And then the last 2 points we need to place are going to be exactly on the midline. So that's at the like kind of quarter of the way mark, like 1/4 of the way through the cycle, and then 3/4 of the way through the cycle. So at pi over 2 and at 3 pi over 2, and then from there we can connect our points. Remember that like those are maxes, so we shouldn't have any points below or above them. So it should, after we hit the max, kind of turn back around and curve over. And this is one cycle of a cosine graph. Okay, moving down to example 2, this is the last one. Write a function to represent the graph using y equals a cosine b of x plus k. So we need to figure out amplitude, frequency, and midline. When we have a graph, I like to find midline first, and then we'll probably do midline, amplitude, frequency. So we'll go a little bit out of order. But the midline, remember, we need to kind of figure out like what's our highest point. It's right there at 7. And then our lowest point is at 3. And then what's like in between the two? So like from 7 to 3, that distance is 4. And then so halfway would just be 2. And so the halfway point is either like 2 below 7 or 2 above 3. But it would be at y equals 5. So I'm just going to draw that in there. Y equals 5. That's like the middle point of our maximum and our minimum. So the midline is y equals 5. The amplitude is the distance from the midline to the maximum or the minimum. So to the highest point or the lowest point. I'm just going to redraw that in there. So for our amplitude, we either have to go up 2 units from 5 to get to 7 for our amp, or we need to go down 2 units from 5 to get to 3 to get to our minimum. So either way, we're going I wrote 3 accidentally. Sorry, go down 2 units to get to our minimum of 3. So our amplitude, either way, whichever way we're going, is going to be 2. So it's not the total distance between the max and the min, it's from the midline up or the midline down. And then I'm going to go ahead and erase those because for our frequency, they don't really help us find it or anything like that. But the frequency is how many like repeating cycles occur over like a span of 2 pi. So if we start at 0 and then 2 pi is over there, we want to see how many times does the cycle repeat itself. So it starts here, goes down, and then comes back up. And then after it comes back up again, it starts to repeat itself. So it goes down, comes back up, goes down, comes back up. And then now like this, that's one cycle. I could literally just copy that over and it's just repeating the same exact pattern each time. So there's 3 of those from 0 to 2 pi. So the frequency is going to be 3. So amplitude is the A in that formula. Frequency is the B in that formula. It's like all the stuff written up here. And then midline is the K in that formula. So we have all the information we need. We just need to go ahead and write them all in now. So it'll be y equals A is amplitude, so 2, cosine, and then bx, so that would be 3 for bx, close parentheses, and then plus the midline, which is 5, so plus 5. So y equals 2 cosine 3x and then plus 5.